This call is now being recorded.
So good afternoon to one and all present here. A very warm welcome to one and all to gather the information from our resource person, Mrs. P. Jennifer ma'am. Welcome you ma'am for this session. We are waiting for your knowledge that should be shared to our students regarding the compiler subject. Thank you ma'am.
Thank you ma'am. Thank you ma'am. Good afternoon students. So let us start our bending compiler design concepts. Okay, we already studied, I think, the remaining phases of compiler. Yeah. So we have seen about the phases of compiler. Started with the lexical analyzer. Then after that, you have seen the syntax analyzer, I think. Then semantic analyzer. Then about the intermediate code generation. Okay, and the bending one is code optimization. Okay, so code optimization is a phase that is after the intermediate code generation and before the code generation, target code generation. You already know about all the phases, right? So shall we move on directly to code optimization, or shall we have a recap of all the phases? And that is what is the output of each of the phase, and what is the input of each of the phase. Okay, and what are the various representation of the output from each phases. Okay, then we move on to code optimization. Huh? Students, shall we move directly to code optimization, or you need a recap of everything, all the other phases? Okay, let us start with the recap of the phases you have already studied in the compiler. Okay, then we move on to the code optimization. Okay, so when you consider the compiler, so compiler that will be divided, that is the process of compiler is converting from one language to another language, that is high level to low level language. So this conversion can be done in various phases. So that is the thing you have seen in compiler design. So it starts with the lexical analyzer. Yeah, I hope you all know about it very clearly. So lexical analyzer, when you consider the gate-based questions, so main question is they will give you a instruction or a statement, and they will ask for how many tokens present in that statement. Likewise, they will surely ask from the lexical phase. Yeah, so lexical phase is nothing but it will take the source code as the program as the input, and it produces the tokens. Yeah, you already know about these terms, token, lexeme, and pattern. You already know about these terms, I think. So token is nothing but it is a cohesive sequence of characters, or we can say set of characters with a logical meaning. Yeah, for example, if I take sum equal to 10, okay, if I take the initialization statement sum equal to 10, then yes, u, and m. These three characters are grouped together and form a meaning called variable. Right, so that is said to be what? Identifier token. And then equal to assignment operator, that is a separate one, and 10 is a constant, so that will be identified as a separate token. So token is nothing but a set of characters with a collective meaning. Yeah, then what comes the lexeme? Lexeme is a set of characters forming the token, will be called as what? Lexeme. Yeah, that is, for example, if I have the sum identifier token, sum means S, U, and M. Three will combine together and form the token, right? So that's why S, U, M are collectively called as the lexeme of the token identifier. And then about the pattern. Pattern represent why you are saying that particular thing as a token, that is said to be pattern. So rules for defining the token will be called as pattern. Yeah, so these are the three important tabs in the first phase, lexical analyzer. So after the lexical analyzer, the details what you have found will be stored, or the tokens what you have found will be stored in the symbol table. Okay, so symbol table you already know about it, I think. Symbol table is nothing but a data structure used for holding the data token about the information about the token. For example, what are the variables? For example, if I take sum is equal to 10 means sum is a variable, right? So what is the type of token sum is? Then what is the data type of the sum? For example, sum equal to 10 means that sum will be declared as an integer. then what is the value assigned to it, and how many bytes will be allocated to it. For example, C or C++ or Java, based on the programming languages, the memory bytes allocated to it will vary, right? So integer, some 2 bytes or 4 bytes. Then float, it will be what bytes. So likewise, based on the programming language you are going to use, the number of bytes allocation will vary. So all these will be called as what? Attributes of token. That will be stored in the symbol table. And this symbol table will be used by all the phases for updating more and more information, right? And the next it comes what we called as the syntax analyzer. So syntax analyzer, it takes the tokens as the input and produces the hierarchical representation, that is the syntactic structure, or what we call as syntax tree or parse tree as the input. So in this phase, what we can accept from GATE question is they can give some there is a set of expression or some tokens, and for this particular thing, what will be the syntax tree? Yeah, I think you already know about how to construct the syntax tree also. So that can be asked in the syntax analyzer. So syntax analyzer, another important thing is it is also called as what? Hierarchical analysis. Likewise, lexical analysis is also called as linear analysis. Okay, so other names can also be used. Yeah, so syntax analysis. So syntax analyzer, it will check the syntax, and if it is okay, it will construct the hierarchical structure. And the next comes the semantic analyzer. So semantic analyzer, it is also called as type checker. Okay, I think you already know about that also. So type checker, it will, for example, if I declare sum is equal to 10 means it will check whether sum and 10 not compatible types. So 10 is an integer, right? So sum is also integer, or it represents a number, or it is going to be incompatible operand like a string or some function call likewise. Okay, so it will check the incompatibility or compatibility of the types. Okay, so that is said to be semantic analyzer. So these are the analysis phases. So after this phase, if everything is okay, then what comes next? The intermediate code generation. So intermediate code generation, it is a process in order to make the conversion of high level language to low level language in a faster way. So that's why intermediate code representations you have used. I think you all know about what are the various representations. The various representations are 3 address code, then comes a hierarchical representation also. It is one of the, that is intermediate representation, then quadruples, triples, so many postfix notation. So these are various intermediate representation. The most important representation is, can anyone post in chat box what is the main representation used in intermediate code? It is a very important thing. Okay, so can anyone tell in chat box what is intermediate code? What is the main representation of intermediate code? Okay, I will tell. So after semantic analyzer, you are having your intermediate code generation, and the main intermediate code representation is 3 address code. Can you remember it now? So 3 address code. Okay, so listen. So the first phase you have already seen. These are the things you already seen, I think, right? Now we are going to see only one phase, the remaining thing, code optimization. So lexical analyzer, you already know about it. That is about the tokens. The output will be tokens. Students, is the screen visible for you? Is the screen visible? Can anyone reply me in the chat box? Because in the intermediately, I have a network problem, I think. Am I audible? Shankar Isi Selvam, am I audible da? Oh, thank you, ma. Thank you. Thank you for the replies. Okay. 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 So lexical analysis, the output will be tokens. So question they will give you a source code. For example, if I take A is equal to B into C. So how many tokens here? 1, 2, 3, 4, and 5. So here 5 tokens are there. Yeah. So the tokens will be identified and stored in the symbol table. And the next one is syntax analyzer, or the process is called a syntax analysis. It produces what? It produces the syntax tree or parse tree. If the syntax is okay, it goes for constructing this hierarchical structure called syntax tree. Okay. So how to construct the syntax tree? For example, A is equal to B plus C means what it will produce, the lexical analyzer will produce as identifier. Let it be ID1 equal to B is also an identifier. Let it be ID2 into 3 is a constant, right? Sorry, C. So C is the identifier, so ID3. Okay. So for this particular tokens identified, what syntax analysis will do is it will produce the syntax tree. Okay. So I think you already know about syntax tree, I think. Okay, let us draw it. Syntax tree draw பண்ணி தெரியும்ல இல்ல பண்ணி காமிக்கவா? Okay. Okay. So what is our expression? Our expression is, sorry, yeah, ID1 equal to ID2 plus ID2 into ID3. Very simple expression. So first, what is the what are the operations involved? Assignment and multiplication, right? So which one has the highest precedence? Multiplication has the highest precedence. So first multiplication, that is ID2 into ID3 will be created. So you all know about syntax tree, right? Syntax tree, the leaves will be the operands and the operators will be the interior nodes. Okay. So how we are going to create is, first the ID3, the left child will be created. The left child or left leaf will be created. That will be ID2. Then right child, that is ID3. Okay. Next, that will be connected by the operator multiplication. Okay. Then that can also be represented with the help of a circle. I think in some book they will represent the interior nodes inside the circle, or it can be represented like this. Okay. Then after that, next operator involved is assignment. Okay. So next operator involved is assignment. So for assignment, what is the right operand? ID2 into ID3 is the right operand. Okay. So here you have equal to, then the left child will be ID1. Okay, so this is your hierarchical tree or syntax tree, right? So you already know about it, I think. Next, that syntax tree will be the output of syntax analyzer. Then comes the semantic analysis. Semantic analysis. So semantic analysis, what will be the output? The same syntax tree. If there is some type information is needed, that will be imported to it. Okay. So here everything is identifiers, right? Just variables. So it will check, the semantic analyzer will check just the types of ID1, ID2 and ID3, whether it is compatible or not. Okay. So that is the only thing they will check. And if it is okay, the same for this particular source code, the same output will be produced. Yeah. So in other case, for example, if I take instead of ID3, it is C க்கு பதிலா ஒரு நம்பர் எடுத்துக்கிறேன்னு வச்சுக்கோங்க. For example, let it be 3 ன்னு வச்சுக்கோங்க. In that case, the semantic analyzer will check whether ID1 and ID2 are also integers, right? Otherwise, it will convert the particular number to a variable type. So for example, if I take ID1 and ID2 types are real or float means, then that number is also converted to float. Okay. So I think you might encounter in C or C++ programming. That is in order to convert the integer number to float. Okay, in that case, what you are doing, float of A. Then A integer will be converted to float. Okay, likewise, we can use convert. Okay, so that is the purpose of semantic analyzer. So semantic analyzer output is syntax tree with type checking information. With type checking information. right? And the next one is intermediate code generation. Intermediate code generation. So intermediate code generation, the input will be syntax tree. So what it's going to produce is 3 address code. Okay, 3 address code. So 3 address code. 3 address code from the name itself, we can define. It is going to have a maximum of 3 address. Okay, that means it can have 3 operands. Okay, so maximum 3 operands irukkalam. 3 operands irukumbodhu, in addition to the assignment operator, it can have only one variable, only one operator. Okay, so I think hope you all know about the properties of 3 address code. Okay, so gate questions means if you know the concept nook and corner, then it is easy for you to attend any question. Okay, otherwise just நீங்க gate based questions அந்த வெறும் நெட்ல உள்ளது மட்டும் நீங்க பார்த்துட்டே இருந்தீங்க அப்படின்னா, if that comes it is well and good. In other case we cannot possible to write a simple question. So nook and corner, if you know the concept, it is easy for you to answer any question. Okay, so 3 address code represent the properties. Are first property is it contain a maximum of 3 operands. Then the operators will be, in addition to the assignment operator, it can have only one operator. Okay, so this is about the properties of 3 address code. Okay, so for this syntax tree will be the input. So the output will be, here they are using the temporary variables. Temporary variable is panvanga, that is, let it be according to temporary variables, we used to hold the temporary results, right? So here, so this is your syntax tree, right? So the first value you are going to compute it id2 into id3. Yeah, so the 3 address code will be, let it be temp1 or t1 or u, whatever it is you can use. It is just a variable. Temp1 is equal to id2 into id3, right? So next comes the assignment operator. Yeah, that is id temp2 temp1 equal to id2 into id3, and that will be assigned to id1. So id1 equal to temp1. Okay, so this is your output for intermediate code generation. 3 address code. It uses the temporary variables, right? So temporary variables are used to hold the intermediate values. Yeah, then this is the output. Okay, next comes, so what we are going to see now, that is the code optimization. Code optimization. So optimization represent, what do you mean by optimization? Optimization represent the optimized result. Likewise, you have seen, right? Optimize means the best result. Or we can, for example, what is the purpose of code optimization is, we can we got the intermediate code, right? That can be directly converted to the target code. Yes, so target code direct convert panilam. Yeah, but why this phase is needed is, in order to get the better result, or in order to fasten the process of converting intermediate code to the target code, we go for code optimization, right? So optimization means, in order to get the fastest conversion, we go for code optimization. Various techniques are there. Then finally, the code generation phase. So code optimization only you are going to see. So code generation. So code generation means, the code generation, the target code, it may be in the form of machine language, yeah, machine language, or it may be in the form of assembly language. Assembly language represent, I think you already know about the code generation phase. Assembly language na eppadi irukum, sub assembler directives use pannirpaangala, sub, mul, add, move. Okay, so those are called as assembly language directives. Okay, so your code can be in the form of assembly language, or it can be in the form of machine language. எப்போ அது assembly language இருக்கும் அப்படின்னா, for example, when your system contains a component called assembler, in that case the compiler will produce the assembly language code, and that assembly language code will be converted to or the target code. So here, or it can be directly converted to the machine code. Okay, so these are the 2 forms of target code. It may be in the form of machine language, that is zeros and ones, and it may, or it may be in the form of assembly language. Okay, so this is about the recap of all the phases what you have already studied in the gate coaching. Okay, now we are going to the gate optimization, that is compiler code optimization phase. So code optimization is nothing but, okay, so you're going to reduce the you code or in three address code. For example, this is a simple example, so no need for code optimization, right? Consider I take some other term id1 equal to id2 into id3 plus 6. Okay, so for this the statement will be first multiplication, okay, and the next one will be temp2 equal to temp1 plus 6. Okay, then id 1 equal to temp2, right? So see here, this is your three address code for this given statement, a plus b into plus 6. Consider this is your code. Okay, so இப்போ பாத்தீங்க அப்படின்னா the code optimization what it will do is it will analyze the data flow between each statement. Data flow represent, for example, when you consider the second statement, the temp1 is the value obtained in the first statement, right? And in the third statement, temp2 is the value obtained in the second statement, right? So this is the data flow. So temp1 is for flow from first statement to second statement. Then temp2 is flow from second statement to third statement. So this is what we call as data flow. So the main concept of code optimization is data flow analysis. If you know how the data has been flown from one point to another point in the program, then only you can reduce the code. Yeah? So இப்போ இதுல பாத்தீங்க அப்படின்னா இந்த 3-line code how you can convert to 2-line code. Yeah, so எப்படி reduce பண்ணலாம் அப்படின்னா the first statement we cannot reduce it, so the output will be the same, that is temp1 is equal to id2 into id3. Yeah, and the next statement and the second and third statement consider பண்றீங்கன்னா it is temp2 is equal to temp1 plus 6 and id1 equal to temp2, right? So temp2 ஓட வேல்யூ நீங்க சப்ஸ்டிட்யூட் பண்ணீங்கன்னா என்ன ஆகும்? id1 equal to temp1 plus 6. It is also a 3-address code, அப்படிதானே? It contains 3 operands, that is id1 temp1 6, 3 operands, and in addition to the assignment operator you are having only the addition operator. Yeah, so no problem about the rules. So these two can be combined together as a single statement. Okay, so these two can be combined together as a simple statement as id1 equal to temp1 plus 6. Okay, so this is what we call as code optimization, that is reducing the number of temporary variables that has been used, or reducing the unnecessary operations, reducing the unnecessary statements, yeah, or using the cheaper ones. Cheaper ones represent, for example, if I take the multiplication can be done with the help of repetitive additions, right? So multiplication and addition, when you compare both the things, addition is the cheapest one. Okay, so likewise that is a technique called strength reduction. So those all comes under the code optimization. Yeah, so this is the purpose of code optimization. In order to fasten the conversion of intermediate code to the target code, as well as in order to produce a better result, your faster running code, you go for code optimization, right? So code optimization, the main concept we need to know about the data flow as well as the control flow. That is, when you consider the program, it may be sequential flow, or it may be, for example, if I take some go to statement. Okay, so go to, in that case what happens, or go to, or if looping statement, or if statement, switch statement, in that case what happens, it will not be sequential. Right? So go to label means there is a jump from one point of the program to another point. So where the control flow, yeah, so that is important. Then where the data flow from one statement to another. So these are the two things that should be very important when you consider the code optimization, right? So next one is, what are the techniques of optimization? Peephole optimization, local optimization, global optimization, and loop optimization. So peephole is nothing but, yeah, taking a small set of statements and find the cheapest one. Already smaller இருக்கிறது இன்னும் எப்படி சிம்பிளா எழுதலாம் அப்படிங்கறத பாக்குறதா என்னது peephole optimization. Yeah, so that is about peephole optimization. Then local and global optimization represent, for example, when you are our coding, consider the block of statements will be represented as starts with the opening brace and ends with the closing brace, right? So local means the optimization performed within a block will be called as local optimization, and between the blocks will be called as global optimization. Then about the loop optimization, we consider while loop, for loop, or do while, whatever it is. So when it is considered with the looping statements, it is said to be loop optimization, right? And the next one, okay. So here are the various optimization techniques. Here, common sub-expression elimination, code motion, strength reduction, dead code elimination, copy propagation, loop optimization. So these are the various transformations we can use in order to produce the optimized code. Okay, let us see one by one. Then after that, we move on to data flow analysis. Finally, that is the end of the theoretical part. Then we move on to see some of the gate-based questions. So, gate line the code optimization related, data flow analysis related, questions when they what is that solution? Okay, so let us start now. Compile time evaluation. So see here, the first step, there are two ways of that is evaluating the expression. The one is constant folding and the second one is copy propagation. Constant folding and the second one is copy propagation. So constant, every name from the name itself you can define. Constant is nothing but the numbers, right? So see this example, you can easily identify this. Constant folding here. What is constant folding? This is your statement before optimization, and this is your answer after optimization. Is everyone able to see this example? Okay. So see here, the first before optimization is what? Area equal to 22.0 divided by 7.0 into or. Then double asterisk represent the power operator. Or square and podula. Yeah, here in Pascal or Fortran, it is represented like this. In our C or C++, it is represented as math.pw method use panala, or we can use cap. Okay, but here Fortran or Pascal, they are using like this. There is a asterisk. It is on the power operator. So 22.0 divided by 7.0. Okay, so both are constants, right? That can be evaluated at compile time itself. So A by B at the runtime only we can find what is the value of A and what is the value of B. But here both the values are constant, means there is no point in defining like this. So this can be folded together and represented like this. Yeah. So the first statement is before optimization. The constant folding constants the fold the operations are applied and you're obtaining the value. So directly it is an optimized one. So this is what we call as constant folding, right? And the next one is copy propagation. Sorry, copy propagation or constant propagation. So constant propagation represent, just see here, this is before optimization. Yes, so before optimization, and this is after optimization. Pi, you already know about the value. The pi value is defaultly, it will be 3.142. There is no change in it. Yeah, so there is no point in declaring like this, initializing like this, and we are putting like this. Directly instead of pi, we can propagate the value of pi here itself. Yeah. So after optimization, instead of declaring pi and initializing pi, we can directly put what? 3.148 is here itself. Yeah. So this is what we call as constant propagation. So these are the two techniques of compile time evaluation: constant folding, constant propagation. Are you following my following the students? Is it okay? Up to now, is it okay? Just we have seen only two techniques. Shall we move on to the next technique? Okay, ma'am. Okay. Yeah. The constant folding, constant propagation is okay. And the next one is common sub-expression elimination. So again, from the name itself, you can define common. There's expressions or sub-expressions that are common that can be evaluated and that will be combined together. Okay, so that is said to be common sub-expression evaluation. So see this example, A is equal to B into C, right? And here, after some other line, you're having X is equal to B into C. So here also B into C, here also B into C. Consider between A and X, there is no evaluation of B and C. Then the ரெண்டு ஸ்டேட்மெண்ட் இடையில B-யும் C-யும் value change ஆகலன்னு வச்சுக்கோங்க. In that case, there is no point in evaluating again here. Okay, so B into C அப்படிங்கும்போது இங்கே B into C தான். அந்த வேல்யூ இங்க இடையில சேஞ்சே ஆகல அப்படிங்கும்போது these can be defined like this. That is, B into C can be calculated once and it is assigned in a temporary variable. And instead of calculating again and again B into C, we can directly put what? A is equal to 10, X is equal to 10 plus 5. Okay, so this is what we call as common sub-expression elimination. Okay, so when it is done within the block means that will be called as local common sub-expression elimination. When it is done between the blocks, the block is nothing but a நம்ம coding பார்க்கும்போது the block starts with the opening brace and ends with the closing brace, right? So within that block means that will be called as what? Local common sub-expression elimination. Otherwise, it will be called as global common sub-expression elimination. Yeah. So இது ஒரு simple example காமிச்சு இது போக என்னது பெரிய example அப்படின்னு எடுக்கும்போது here C here என்ன பண்ணிருக்காங்க? It is common C is equal to A plus B. Likewise, they are having. So A plus B is again they are calculating for F also, right? So here C, consider C and F. Here also A plus B, here also A plus B. So between this, there is no redefinition of A plus B. In that case, there is no need of finding again A plus B, right? So instead of it, we can put the value of A plus B in some variable and just assign C equal to T1, right? Likewise, F is equal to T1. Okay, so this is what we called as common sub-expression elimination. Because temporary variables use பண்றது நார்மல் வேரியபிள்ஸ் மெமரி வேரியபிள்ஸ் பார்க்கும்போது யூ ஆல்ரெடி நோ வாட் ஒரு ரெஜிஸ்டர்ல ஸ்டோர் பண்றதுக்கும் மெயின் மெமரியில ஸ்டோர் பண்றதுக்கும் டிஃபரன்ஸ் இருக்கு. ஏன் ரெஜிஸ்டர்ல நம்ம இன்டர்மீடியட் வேல்யூஸ் ஸ்டோர் பண்றோம்? in order to get the faster access. Okay, so that's why with the help of a common sub-expression elimination we can optimize the code. Okay, so this is the next technique. And next one is okay, code motion. So motion represents moving the code from one position to another will be called as what? Code motion. But when you are careful about it, when you are moving the code from one part of the program to other, the algorithm or the concept should not be modified. Okay, ஒரு இடத்துல இருந்து இன்னொரு இடத்துக்கு கொண்டு போறீங்க அப்படின்னா it should not modify the concept of your program, or they should not define the algorithm, change the algorithm of your program. Okay, so that is said to be code motion. So this actually code motion is an important technique in loop optimization. So when you're considering the while loop or for loop or something, so code motion is an important technique. You see here, yeah. So here when you code motion example, there is code space reduction. So here if A is less than B, then Z is equal to X cap 2. There is A square. Yes, XY equal to X square plus 2. So X square is the common term, right? So this X square can be found outside the block. Okay, if block outside can be moved. Okay? So if then you're just assigning Z equal to 10 and Y equal to 10. Okay, so algorithm here is the data that has been passed doesn't change. Okay, so this is it to be code motion, right? And the next one, this is another example. Okay, so this is a code motion when you consider the looping statement. See here, while of I is less than max minus 2. Consider max as a fixed value or static constant value. If never changes means what happens? Then max minus 2 will not be changed. Okay, max minus 2, for example, max is fixedly 10 means 10 minus 2 means it is 8 only, right? So how many times the loop executes, it is always 8. So there is no point in the calculating max minus 2 again and again. Over time while loop execute ஆகும்போது இது calculate பண்றது waste. In that case, what we can do is moving the code out of the loop. Okay, so என்ன பண்ணிருக்காங்க பாருங்க, loopல உள்ள என்ன பண்ணிருக்காங்க, out of the loop they are deducing. So T is equal to this temporary variable equal to max minus 2, then while of I is less than T. Okay, so this is code motion. This is one technique of loop optimization. And the next one is strength reduction. What I told you about, என்ன பண்ண சொன்னேன், இந்த multiplication is can be represented as repetitive addition, right? Likewise, when you consider the power operator, it can be represented as a multiplication also. Okay, so likewise, the best one or cheapest one will be called as what? Strength reduction, replacement of an operator with a less costly one. Yes, here what they are doing is instead of using the repetitive addition. Okay, so in this way we can reduce the strength of the code. And the next one is dead code elimination. So dead is represent, it is no more. Okay, right? So dead code, in our programming construct, it is said to be the statements that never be executed. என்ன input கொடுத்தாலும் சில statement execute ஆகாது அப்படின்னா, there is no point in keeping the statement. Okay, so such statements can be identified and should be deleted. See this example. Okay, bold it. Okay, debug is a variable and it is initialized to 0. Consider there is no way debug has been changed to 1. Okay, now consider this if block, if of debug. Okay, so if of debug means if of 0. If of true nar matana enna pannom, this will be executed, the print statement will be executed. That means this print is never executed because the debug is initialized to 0 and there is no statement for converting, changing the debug value. Yeah, so such dead code. So this is said to be dead code and should be deleted. We have seen. Then after the code motion, right? So these are the various optimization techniques. And the next one is copy propagation. So copy propagation, very simple one, like constant propagation. See here, x of I is equal to a, right? And sum is equal to x of I plus a. What is the meaning of it? X of I is already actually a, right? So there is no point in referring again the array variable. Okay, so there is so instead of it, we can directly put what? Sum is equal to a plus a. Okay, so this is copy statement. So from this copy statement, we can directly put instead of x of I, we can put a. So this is about the copy propagation, right? So these are the various techniques. And about the loop optimization. Loop optimization is nothing but decreasing the number of instructions in the inner loop. Yeah, the concept. What you are doing is you are just removing or decreasing the number of instructions that is present inside the. Yeah, so that is said to be loop optimization. I already told about the code motion, right? The code motion, moving the code from the loop to the outer side. And strength reduction we already seen. The induction variable element is nothing but when you are using the loop means we are using I equal to for I equal to 0. Likewise, you are using some induction variables. So without changing the concept, if possible, we can move the I variable outside, means that can also be done. Okay, so I variable related our index variable, if you are removing or if you are moving outside the loop, then you have to make some changes inside the loop. Okay, but if possible, we can eliminate it. So these are the 3 ways of loop optimization, right? So this is about the various techniques. You have seen various techniques now. And after that, peephole optimization, what I told you, we are considering a small set of statements, and from the small set of statements, we are finding the best smallest. Okay, so that is it to be peephole optimization. Yeah, so here the various peephole optimization techniques are redundant instruction elimination. Redundant represent the same thing will be repeated. Okay, so that can be eliminated. Yeah, you're going to use algebraic identities, algebraic laws, commutative law, associative law, that can be used. Then flow of control optimization. Okay, that unnecessary jumps can be avoided. Okay, then you can use the machine idioms, right? Then about the redundant instruction, as you see this example, redundant move r naught comma a, that is moving the value of r naught to the a variable, and the next line itself again we are moving the value of a to r naught. So this is unnecessary, right? Just you are taking a thing from a place and take it to another place, put it in another place. And from the same thing, you're doing reverse pandringa. There is no point in doing that. Okay, so such thing can be avoided. Okay, so this should be avoided. And the next one is unreachable code. Dead code animation pathonla. See here has defined debug 0. That means the macro debug is initialized to 0. That means the debug is always 0. In that case, this statement will never be executed, right? So this should be avoided. Okay, so this is unreachable code. And algebraic identities, you already know about the algebraic laws. A into 1 equal to A. So there is no point you use that, right? Cap, that is, instead of power operator, you can use multiplication. Instead of multiplication operator, you can use repetitive addition. Likewise, using the cheapest one will be called as strength reduction, right? And the next one, these are the various one. And the next one is unnecessary jumps. See here, there is a jump to label 1. Then in label 1, there is a jump to label 2. Yeah, so this is a very unnecessary jump. ஒரு இடத்துல ஜம்ப் பண்ண சொல்றோம், அங்க போறோம், அங்க போய் இந்த ஸ்டேட்மெண்ட் எக்ஸிக்யூட் ஆகல, டைரக்டா அங்க இருந்து ஒரு ஜம்ப் ஆகுது. Yeah, so this is an unnecessary jump. So it can be replaced by directly jump to the lab 2 the time execution between this will be avoided. Okay, so this can be reduced, should be reduced. Yeah, and the next one, another example, again the same thing. Instead of using this jump, you can be replaced by directly putting RET here. Yeah, so this is can be avoided. And the last one is use of machine idioms. So machine idioms, for example, if you want to calculate I equal to I plus 1, I can use the assembler code like this, right? Add I comma hash 1. Okay, so that means I value and one value will be added and the result will be stored in I. Okay, so instead of it, I can use the assembler directive instruction also. Okay, INC1. Okay, so the thing is, you have to use special hardware instruction which may be less costly. So this is the various peephole optimization technique. Yeah, so up to now we have seen various techniques. So these are the various techniques in order to optimize the code, right? So up to now, any clarifications? Then we move on to a concept called DAG and finally data flow analysis. Any clarifications or move on to the next one? Any clarification, student, or move on to the next one? Students, is anyone inside? Kindly answer me. Okay, okay. Let's move on to the next one. I think you already know about this. And the next one is local optimization. Yes, so you are going to optimize the code that is present inside the basic block. Okay, with the help of a concept called DAG. Okay, so DAG is nothing but directed acyclic graph. Okay, DAG is nothing but a directed acyclic graph. So the main purpose of DAG is used to find the common sub-expressions and eliminate it. Okay, so common sub-expressions are easy way by constructing the DAG. Okay, so directed acyclic graph. So directed acyclic graph, let us directly go on to an example how to draw the graph. So when you consider this graph, how we are going to draw is, first the for any given source code, you have to convert that to the intermediate code, that is 3 address code. Yeah, then after that what you have to do is, from the intermediate code, we are going to construct this DAG. So how we are going to construct this? You have to consider every separate statement. That is, first one, let it be T1 equal to 4 into Y. So the first left operand is 4. So 4 will be created, right? And the I will be created, right? And the next operation involved is asterisk. So asterisk will be created, right? Then that is equal to what? T1. So T1 will be the label of this subtree. Yeah. Then the next one. Okay, T2 equal to A of T1. So T1 equal to 4 into I. Next என்ன பண்ண போறோம்? T2 equal to A of T1. So what are the operation involved? Array, then assignment. Okay, first array. Array between A and T1. Okay, so இப்போ பாத்தீங்க அப்படின்னா array போடுறீங்க. Then the left child will be A and the right child will be what? T1. T1 is what? 4 into Y. So this is subtree is your T1. So this is your T1 right child. And the next after that, which is equal to what? T2. So T2 போட்டாச்சு. So difference between DAG க்கும் syntax tree க்கு என்ன difference அப்படின்னு பார்த்தேன்னா syntax tree என்னது? The same thing you are using. For leaves ல என்ன இருக்கும்? It contains the operands. Then at the integer nodes you are having the operators. Right? But extra in you are having the labels. அது போக அங்க வந்து இப்போ ஃபார் எக்ஸாம்பிள் A of T1 அப்படின்னா என்ன பண்ணாது? T1 இதை கன்சிடர் பண்ணாது. They will take that is இப்போ A of T1 கூட எடுத்துனோம்னா இன்னொரு ஸ்டேட்மெண்ட் வருது. That is also 4 into I அப்படின்னா it will consider separate. A separate node will be created and 4 into I you are creating. Then that will be T3, right? But here DAG will first check whether it is already present in the tree or not. Therefore, it will be put like this, comma T3. Am I audible? I think I have a little bit better problem. Gandhimati, am I audible now? Okay, okay, ma'am. இடையில ஏதாவது கிளாரிபிகேஷன்ஸ்னா you ask me. சரியா? So DAG already பார்த்துட்டீங்களா? இப்பதான் பாக்கீங்களா? Directed acyclic graph already பார்த்துட்டீங்களா? இப்பதான் பாக்கீங்களா? Okay. Okay, so DAG, see here, T3 is equal to 4 into I. 4 into I is already there. So you have to put what? Just up and the left side operand. So T3, right? And the next one, T4 equal to B of T3. So here array is the operator. The left child is B and the right child is T3. T3 in there, and let it be T4. Okay. And the next one is T5 is equal to T2 plus T4. T2 here and T4 is here and the operator will be plus and it will be T5, right? Then I equal to T5. So directly you can put I here. Okay. So from this tag, you can tell what are the common sub expressions. See here, comma, comma, comma. That means I equal to T5 and T1 equal to T3. Okay, so from this we can find the common sub expressions. Then after that, what you can do is just என்ன பண்ணிக்கலாம்? இங்க 4 into y, இங்க 4 into y. அப்ப என்ன பண்ணிடலாம்? T3 can be eliminated. Okay, so T3 can be eliminated. Okay, see here. So T3 can be eliminated and instead of T3, wherever T3 is present, you can put directly T1. Okay, so after optimization, உங்களுக்கு எப்படி மாறும் அப்படின்னா anyway, yeah, so after optimization, what you got is T1 equal to 4 into y, T2 is equal to A of T1, T3 is equal to 4 into y already is present here. So T3 equal to T1, that means it can be deleted. Then T4 equal to B of T1, right? B of T1 and T5 equal to T2 plus T4. Okay, so one statement has been reduced because it is common. As well as I equal to T5, right? In that case, what happens? This can be deleted and instead of T5, you can directly put I. Okay, so this is your optimized code. Okay, see here, the 6 statements will be reduced to 4-line statement. Okay, so this is what we call as DAG. So the DAG purpose is finding the common sub expression and from which you can delete it. right? So another example, according to your textbook, there is Alfred Viaco. There is, they are given some statement. See here, A is equal to B plus C, B is equal to B minus D, and C equal to C. See here, here B plus C, here also B plus C. But whether they are same பாருங்க இல்ல ஏன் பாருங்க, here after the definition of A, yeah, B and C has been changed. B value has been changed, C value has been changed. That means this B plus C is not equal to this B plus C. Okay, so that's why we got the DAG up like this. பாருங்க, the DAG is different. So there is no optimization is needed. Okay. When I consider this example, A equal to B plus C, then B is equal to A minus D, then D is equal to A minus D, C equal to D plus. See here, which are common? A minus D is common. Yeah, that means B equal to D. அப்ப வந்திருக்கா tag பாருங்க, B, D இருக்கா, that means B equal to D. In that case, we can delete B or we can delete D. எது வேண்டாமோ நம்ம delete பண்ணிக்கலாம், because அதுக்கு future use இல்ல. So after that, what the C is equal to D plus C. Yeah, because after B definition, B வந்து எங்கேயுமே யூஸ் பண்ணல. So there is no need for B. Okay, so this is your optimized code. Okay, this is before optimization, and with the help of DAG, you are finding the common sub expression, and after optimization, you are having this code. Okay, so this is about the various optimization techniques. So various things we have seen. The last one is the common sub expression elimination. In order to find, identify, and eliminate the common sub expression, we go for constrating the DAG. So DAG is similar to syntax tree construction. The difference is it will check before creating a new node. It will check whether it is already present or not. Okay, if it is there, it will not create again and again. Yeah, so that is the common sub-expression elimination using that. The last concept is today for theoretical concept is global data flow analysis, right? So global data flow analysis. So as I told in the first initial part itself, what do you mean by data flow analysis? Data flow represent why we go for data flow analysis, why it is needed. Here we are performing what? Optimization, finding the best result. Yeah, அப்படிங்கும்போது we need to know where the data. இப்போ இந்த previous example எடுத்துக்கோங்களேன். இப்படி நம்ம சிம்பிளா பார்த்தா you can tell this A is equal to B plus C, here also B equal to B plus C. But what happens here? This B is somewhere, some value, and this B is actually taken from this definition, right? Likewise, this C is taken from this definition, right? So how do I know? By based on the flow of data only, I can optimize the code. இப்போ நான் இதை optimize பண்ண முடியாதுன்னு சொல்றேன், அதே இது இந்த set of statements optimize பண்ண முடியும்னு சொல்றேன். ஏன்? Here because in the previous one there is no common, but here this A minus D, here A, both A are same and D also same. Yeah, this is what we call as data flow analysis. Yeah, so the main part of optimization is data flow analysis. Without having the knowledge of data flow analysis, we cannot optimize the code. Okay, so this data flow analysis can be defined by a equation, data flow equation called out of S is equal to gen of S union in of S minus kill of S. So these are some data sets. Okay, the data sets that contains the information about the various data you're going to gather while the program is executing. So S is nothing but a statement. So in of S represent information goes into S. S represent a statement. For example, A is equal to B plus C, right? So what is the value of B that is going to that statement? What is the value of C going to the statement? That is in of S. Kill of S represent what is the information that is killed at the exit of the statement. Okay. Previous B ஓட வேல்யூ ஏதாவது இருக்கு, இப்போ நெக்ஸ்ட் ஸ்டேட்மெண்ட்ல B equal to A plus B அப்படின்னு போகும்போது என்ன ஆகுது? B ஓட வேல்யூ சேஞ்ச் ஆகுது. The last previous B value has been killed, right? That is kill of S. And gen of S represent what is a new value or new information you got by executing that statement. that is gen of s. And the last one out of s is at the end of the statement, what is the information you got? Okay, that is what is the value got at the end of the statement. So with the help of these 4 data sets, they are defining this equation. Out of s is equal to gen of s union in of s minus kill of s. Right? Then for this, they are defining a graph called control flow graph, a CFG. So control flow graph is nothing but they will divide the program into blocks. B1, B2, B3, B4, B5, and B6 are called as blocks of statements. Coding opening brace, closing brace, just it is a diagrammatical representation. Yeah. So based there is a algorithm for defining the blocks also. It is when you are given with the code, you can find the leaders of the particular block. Leader is nothing but the first statement inside in a block. So the leaders when you are considering any code, the first statement is a leader. The second one is the statement of go to is a leader. Go to 3 abina, third line la enna statement irukko adu leader ah irukum. Okay. Likewise, go to statement is also leader. Go to statement enge irukko adu leader ah irukum. Adhu mari go to adutha statement leader ah irukum. Likewise, there are some rules are there. Okay. So based on the rules, we can construct the control flow graph. Okay. So B1, B2, B3 are nothing but the block. So here they are defining some 2 important terms, point and path. So point is nothing but when you are considering any statement, point represent before and after the instant. Okay, so that is said to be point. For example, if I take the B1 block, 3 statements, right? So 1, 2, first statement before, after. Then 3, 4. So when you consider the B1, it contains 4 points. Okay, 1, 2, 3, 4. B2 2 points. Okay, that is every statement before and after path of another point. And next path represent the set of points or the execution path of the points. Okay, so that is said to be path. Okay, so this is about the path and point, and this is the example control flow graph. Okay, so next one is you are going to see some terms reaching definition, UD chain. Okay, so some terms are there: reaching definition, live users of variables, and definition use relations. Next, DU and UD chains. Okay, reaching definition is nothing but, for example, see this example. If you on inferring this, you can see the concept. See here at a particular instant, x is assigned with the value of something. Okay, this definition of x is reachable at this particular location if and only if there is no other definition of x. Yeah, இந்த இடத்துல என்ன பண்ணிருக்காங்க, x is equal to ஒரு definition வச்சிருக்காங்க, right? So இது இந்த இடத்துல என்ன யூஸ் பண்ணிருக்காங்க, x ஓட வேல்யூவை யூஸ் பண்றாங்க. இந்த ரெண்டுக்கும் இடையில x க்கு வேற definition இல்ல அப்படின்னா this definition will be reached in this particular instance. That is said to be RD, a reaching definition. Then live uses of definition அப்படின்னா the same thing. Here x is equal to you are saying defining something, and here there is no other definition. That means this particular definition or this value is live at this point. Yeah, so that is said to be live uses of variables. And the next one is definition use relations. The same thing. Here you are defining எல்லாமே ஒரே கான்செப்ட் தான் சொல்லும். Define reaching definition, use definition. நீங்க define பண்ணிருக்கீங்க, அது யூஸ் பண்ண முடியுதா, அதுதான் என்னது reaching. Okay, so this is said to be UD chain and DU chain. Okay, so give you an example. See here, this is DU chain for R1. Okay, R1 எடுத்துக்கோங்க. This is the R1 value, right? From R1, where it has been used, it has been used in R3. So R1, it is in the location 1. So 1, 2, 3, then comma 4. Okay, so அதுக்கு இடையில என்ன ஆகல, R1 வேல்யூ சேஞ்ச் ஆகல. இந்த R1 வேல்யூ தான் எங்கேயும் இருக்குது, 3லயும் இருக்குது, 4லயும் இருக்குது. Okay, likewise, and the next one is 4. Okay, இங்க R1 நம்ம ரீடிஃபைன் பண்ணியாச்சு. அப்போ இந்த R1 வேல்யூ வந்து எங்க வரைக்கும், அதுல டெட் ஆயிடுச்சு, புதுசா வேல்யூ கண்டுபிடிச்சாச்சு. This R1 will be reachable up to R5. இங்க யூஸ் பண்ணிருக்காங்களா? So this is said to be DU chain. Define பண்ணிருக்கோம், அது எது வரை யூஸ் பண்ண முடியும். Then அதே UD chain பாருங்க. UD chain என்னது, பின்னால இருந்து வரும். For example, if I take UD change of R1 last 12ல யூஸ் பண்ணிருக்காங்க. அதோட டெஃபினிஷன் எங்க இருக்கு? 11ல இருக்கு. ஓகே, அதே மாதிரி R7 எடுத்துக்கோங்க. R7 10. R7 has been used in 10 and previously it has been defined in 6 as well as it has been defined in 9. Okay, so this is said to be UD chain. Okay, so இத வச்சு கூட அவங்க என்ன கேட்பாங்க? Write the UD chain and DU chain of particular variable. Okay, likewise they may ask. Okay, so this is about the various relations. And the last one is data flow analysis of a structured program. So when you consider any program, it may be divided into various parts. It may be a single statement, A is equal to B plus C, that is identifier is equal to expression. Or it may be a set of statements. Or it may be if, then else. Or it may be do while. Okay, so an expression, it may be an addition or it may be some arithmetic operation or simply a identifier. Right, so for all these constructs you are going to see the data flow equation. Okay, so see here, this is your control, this is flow graph, and I show you the equation. See here, a statement yes, right, let it be A equal to B plus C, and the definition let it be D. சரியா, நம்ம இப்ப என்ன டிஃபைன் பண்ண போறோம்? டேட்டா ஃப்ளோ ஈக்குவேஷன் டிஃபைன் பண்ண போறோம். இப்ப gen of s னா என்ன சொன்னேன்? The new information generated at this statement. What is the information generated? It is D, right? So gen of s is equal to D, right? And kill of s, இந்த particular definition எப்போ kill ஆகும்? A க்கு இன்னொரு definition வந்துச்சா, அப்படிதானே? So kill of s is equal to DA. DA is nothing but the set of definitions for the variable A. Okay, so அந்த டெஃபினிஷன் அதுல இருந்து D வந்து கில் ஆகுறது and minus D. இதை தவிர்த்து அடுத்து ஒரு டெஃபினிஷன் ஏக்கு வருது. A is equal to 10 or A equal to D plus E. Likewise, you are having some other definition, means then this statement will be killed. Then according to the data flow equation, what is that? Out of S is equal to gen of S union in of S minus kill of S. Okay, so this is about the single statement data flow equation. Right, and the next one, there is set of statements S1 S2. So here what is gen of S? This is S1 or S அப்படினு பாக்கும்போது ரெண்டு ஸ்டேட்மென்ட் கன்சிடர் பண்ணிருக்காங்க, S1 and S2. So gen of S is equal to S2 generate ஆகும், S1 generate ஆகும், and not kill of S2. Minus kill of S2 is represent என்ன சொல்லிருப்பாங்கன்னா not killed. Cannot killed of S2. So both has been generated, means then gen of S is, that will be equal to gen of S. Then kill of S is equal to same thing. Okay, S1 will be, S2 will be killed or S1 will be killed. Okay, and negation of S2. Okay, ஒன்னு S1 kill ஆகி அப்படியே வெளியில வந்துரும், இல்லனா S2 generate ஆயிருக்குன்னா S2 kill ஆயிரும். So that is the kill of S. And the next, in of S1 equal to இதான் entry point. அப்படிதானே, S1 ஓட entry point னா S ஓட entry point. Then in of S2 அப்படின்னு பார்க்கும்போது இந்த point என்ன point? S1 ஓட out. Okay, so in of S2 is equal to out of S1, right? And out of S, this point, what is this point? Out of S2. Yeah, so in of S1 is equal to in of S, and in of S2 is equal to out of S1, and this point out of S is equal to out of S2. Okay, so this is the data flow equations for this set of statements. And next one is if then else. Okay, இது நீங்களே எழுதலாம். இப்ப அத கான்செப்ட் புரிஞ்சுனா நீங்க ஈஸியா எழுதலாம். இப்ப பாருங்க, yes if then else. If then else னா என்ன? If it is true, then S1 will be executed. Otherwise S2 will be executed. ஏதாவது ஒன்னு தான் எக்ஸிக்யூட் ஆக போகுது, அப்படிதானே? அப்ப பாருங்க, gen of S is equal to gen of S1, that is S1 will be generated, or union represent or S2 will be generated. Then kill of S, when the S will be deleted or killed at this point. Okay, at this point, this is a common point. Whether S1 kill ஆகி இந்த இடத்துக்கு வந்திருக்கும், இல்ல S2 வரு, அப்போ இந்த இடத்துல என்ன ஆகும்? Both S1 and S2 will be killed. That is kill of S is equal to kill of S1 and kill of S2. Right? Then in of S1, that is in of S, and in of S2 is also in of S. Then out of S அப்படின்னு பார்க்கும்போது ஒன்னு S1 வழியா வந்திருக்கும், or it will reach with the help of S2. Right? So out of S is equal to out of S1 or out of S2, right? And the last one is data flow equation for the while. Okay, so while பார்க்கும்போது என்னாவது do while. Okay, there is two S1 will be executed, and after that condition will be checked and it will be repeated again and again. So gen of S is equal to S1 will be generated. When it is kill, S will be kill. And in of S அப்படின்னு பார்க்கும்போது S1 அப்படின்னு பார்க்கும்போது in of S மட்டும் வராது, இது லூப்பிங்கிறதுனால மறுபடியும் என்ன ஆயிட்டே இருக்கும், ஜென்ரேட் ஆயிட்டே இருக்கும். Then out of S அப்படின்னு பார்க்கும் this point, so that is equal to out of S1. Okay, so this is about the data flow equations of various structural language construct. So any clarification in data flow analysis? Students, any clarifications in data flow analysis? Any clarification? Or shall we move on to the next liveless analysis and end up the theoretical concept and move to the MCQ, gate-based questions? Okay, ma'am. Okay, so see here. So this is about the data flow analysis, and the last one will be, it is live variable analysis. So this is what we called as liveness. இப்போ பார்த்தே இதுதான் பாருங்க, live எப்போ சொல்றோம், for example if you are taking some definition and when it is reach a particular point, சரியா, எந்த அடுத்து அதோட டெஃபினிஷன் வர்ற வரைக்கும் அது லைவா இருக்குன்னு அர்த்தம், சரியா. then after the next definition it will be dead. Okay, so எது வரைக்கும் அது லைவா இருக்கு, so that will be said as liveness analysis, live variable analysis. So liveness represent for each point in a program and each variable y, determine whether y can be used before being redefined. Redefine பண்ற வரைக்கும் அது லைவா இருக்கும். Okay, so that can be defined. See this example. So இத வந்து கேட்பாங்க, one of the important gate based question. See here, consider this graph. Here in this block, R1 is equal to R2 plus R3, then R6 is equal to R4 minus R5. Okay, so at the end of this, there is no R2, R3, R4, R5, and 4 variables are live, right? Because அதுக்கப்புறம் எந்த டெஃபினிஷனும் இல்ல. ஆனா இந்த இடத்துக்கு வரும்போது என்ன ஆகுது, R4 வந்து என்ன ஆகுது, டெட் ஆயிடுது. ஏன்னா இங்க உள்ள R4 வந்து it has been redefined. R4 அதுக்கு முன்னால ஏதோ ஒரு வேல்யூ டிஃபைன் ஆயிருந்திருக்கு, இப்போ அந்த R4 வேல்யூ என்ன சேஞ்ச் ஆயிருக்கு. That means this R4 is dead. Okay, so R4 will be live up to this point. Then about R2, R3 and R5 it will be live for the whole thing. Yeah, so that is said to be liveness. ஒரு இடத்துல define பண்ணிருக்காங்க, next அது redefine பண்ற வரைக்கும் that is said to be live. Okay, so that is said to be what? Liveness analysis. Okay, I think we have seen all the concept, bending concept, what Pesley ma'am said. That is, we started with optimization. Why we go for optimization? We have a recap of all the phases, right? Then why we go for optimization? What is important in optimization? Control flow analysis, data flow analysis. Then we have seen the various optimization techniques: peephole, local, global, and loop. Okay. Then we have seen the various ones. That is constant folding, the constant propagation. And the next one, main important thing is common sub-expression elimination. Next one, code motion. Next one, dead code elimination. Then copy propagation, loop optimization, peephole optimization. So in peephole optimization, we have seen the various techniques, right? And the next we have seen is the local optimization with the help of DAG. So the DAG purpose is in order to eliminate the common sub-expression. Okay, so DAG எப்படி construct பண்ணலாம் அப்படிங்கறதையும் example வச்சு பார்த்தோம். Okay, then we move on to the data flow analysis. Data flow equation has been defined. Then we have defined some terms. That is, what is reaching definition. Then DU chain, UD chain. Likewise, we have seen. Then finally, we end up with the liveness analysis. Okay, so this is about the theoretical concept. So any clarification regarding the theoretical concept? Any clarification, student, or shall we move on to the some gate-based questions? Shall we move on to the gate-based questions? Okay. Okay, ma, thank you. Okay. Okay. Okay, some gate-based questions I have searched for it. Still more in net. You can refer it. Okay. So which one of the following is false? Okay, see here. You also try, then we can see the answer. Which one of the following is false? See here, the first one is a basic block is a sequence of instructions where control enters the sequence at the beginning and exits at the end. So basic block block is nothing but the set of statements. So this is a block. This is the block. Up in the block control வந்து எங்க வரும் உள்ளுக்கு வரும் வந்துட்டு என்ன போகும் இந்த ஒரு பாயிண்ட்ல இருந்தா வெளியில போகும். ஓகே அதே மாதிரி எது எடுத்துக்கிட்டாலும் there is one point entry and one exit point. Okay, so the first statement is true. Okay, it's a sequence of instructions where control enters. Size increase பண்ணிக்கிறேன். Kindly wait. Okay, so the first statement is true. That is, the control enters a sequence at the beginning and exits at the end. Then another one. Available expression analysis can be used for common sub-expression elimination. Okay, so you already know about common sub-expression elimination, right? That is the B plus C. A is equal to B plus C. Then in another tab, D is equal to B plus C means both are same if there is no such definitions of B plus B and C, right? So from the available expressions, we can easily find the common expression. So this is also true. And the next one, live variable analysis can be used for dead code elimination. Okay, lastly, we have seen the liveness analysis, right? So in the liveness analysis, we can find what is that. We can find which is dead and which variables are live. Okay, so which variables are live and which are dead, right? So the third one also, it is true. Third one also, live variable analysis can be used for dead code elimination. And then last one, x is equal to 4 into 5. Okay, that implies x is equal to 20. Is an example for common sub-expression elimination. This is actually x is equal to 4 into 5. Repeat x is equal to 4 into 5. That can be replaced by x is equal to 20. Is an example of, can anyone tell me? It is an example of one of the technique. What is the name of that technique? I show you that. I show you the example. See here. என்ன பண்ணிருக்காங்க பாருங்க 22.0 divided by 7.0 can be replaced by 3.14286. அதே இதுதான் இங்க போட்டிருக்காங்க அதே மாதிரி தானே. That is x equal to 4 into 5 can be replaced by x into 20, x equal to 20. So this is an example of what? Constant folding. So this is not an example of common sub-expression elimination. The common sub-expressions இருக்கிறதே ஒரே ஒரு term தான் statement தான் கொடுத்திருக்காங்க. Okay, so in that case this is not an example. So your answer will be this. Okay, likewise you have to. Okay, so this is your answer. Okay, and the next one. Some code optimizations are carried out on the intermediate code. நம்ம intermediate code க்கு அடுத்ததா நம்ம என்ன கொண்டு வரோம் code optimization கொண்டு வரோம். What is the reason? என்ன reason? What is the reason? This is the answer for you. Okay, and the next question is code optimization are carried out on the intermediate code because the first one is what is they are doing? They enhance the portability of the compiler to other target processors. The second one is program analysis is more accurate on intermediate code. The third one is the information from data flow analysis cannot otherwise be used for optimization. And the last one is the information from the front end cannot otherwise be used for optimization. Okay, so actually all these things will be, there is a, apart from B, program analysis வந்து இங்க தான் அக்யூரேட்டா இருக்கும் அப்படிலாம் கிடையாது. You can directly convert the syntax tree into target code also. Okay, but the main thing is, in order to produce the efficient, faster running target code, portable target code, we go for what? Optimization. Okay, so this is not true. That is intermediate code la da program analysis accurate ah irukku solla mudiyadhu. Namma data flow analysis information important da. அது இருந்தா தான் நம்ம என்ன பண்ண முடியும், ஆப்டிமைசேஷன் கொண்டு வர முடியும். ஆனா அதனாலதான் என்ன பண்றோம்னு சொல்ல முடியாது, intermediate codeல optimization பண்றோம்னு சொல்ல முடியாது. The main reason is it will increase the portability of the compiler. That is, it will, in order to produce the faster running code, you have to enhance the portability of the compiler, right? So this is your answer. Yeah. Then the next one, which one of the following is false? Okay, so in most of questions எல்லாமே ஆப்டிமைசேஷன்ல எப்படி இருக்கும்னா, இப்படி MCQs இருக்கலாம், இல்லைன்னா நான் காமிக்கிறேன் பாருங்க. இப்படி ஒரு கோட் கொடுத்து they will ask how many points and paths, or they will ask how many blocks you can identify. Okay, so likewise they will ask, இல்லைன்னா ஒரு கோட் கொடுத்து write the optimized code. Okay, likewise they may ask. Yeah, so see here, the next one is which one of the following is false. The first one, the code contains loop invariant computation. Okay, the loop invariant computation represent invariant variables in pathomla, that is loop invariant variables. I equal to j equal to loop la use பண்ணுவோம்ல அது. And next one is there is scope of common sub expression elimination in this code. Okay, and there is scope of strength reduction in this code. There is scope of dead code elimination in this code. Okay, so in this your answer will be the scope of dead code elimination in this. I think kindly wait. Actually, for this statement, what is the thing we can do? இந்த கோட் கொடுத்திருக்காங்க, இந்த கோடுக்கு என்ன பண்றாங்க அப்படின்னா, okay, so இந்த கோடுக்கு sorry I think something is missing. Actually இதுல என்ன பண்ணிருப்பாங்க அப்படின்னா, they will given a code, ஒரு கோட் கொடுத்து இதுல வந்து என்ன பண்ணலாம், லூப் இன்வேரியன்ட் பண்ணலாமா, காமன் சப் எக்ஸ்பிரஷன் பண்ணலாமா, or strength reduction is possible or not, or dead code is elimination is possible or not. Yes, I think here some code is missing. I think copy பண்ண இது பண்ணிருக்கேன். So kindly refer to it. So இதுல வந்து என்ன பண்ணிருப்பாங்க, just they will tell you the code, some code கொடுத்து likewise இப்படி set of statements கொடுத்து இதுல வந்து loop invariant is possible, then common sub expression பண்ண முடியுமா, strength reduction பண்ண முடியுமா, dead code elimination பண்ண முடியுமா அப்படிங்கறத கேட்பாங்க. Okay, so I think இந்த question இல்ல, நான் வந்து வேற question இதே மாதிரி காமிக்கிறேன். So let us move on to the next one. That is, consider the intermediate code given below. So this is your intermediate code they are given. The number of nodes and edges in the control flow graph. Okay, so for this code, what you are asked is you have to construct the control flow graph. Then from the graph, you have to define how many nodes and edges. Okay, so for that, you have to know how to construct it. Okay, so எப்படி construct பண்ணோம் அப்படின்னா, okay, I already told you have to find the leaders. Okay, leader is nothing but ஒரு blockல உள்ள first statement தான் என்னன்னு சொல்லுவாங்க, leaderன்னு சொல்லுவாங்க. Okay, என்ன எப்படி கண்டுபிடிக்கணும், the first rule is the first statement is a leader. So I highlight பண்ணி காமிக்கேன், first statement is a leader. Okay, so here I equal to 1 is a leader, right? Then go to label இருக்கும்ல, அந்த statement leader. So go to 3, right? So this is a leader. So this is leader. And the next one, go to 2. So 2 is also a leader. Yeah. So first one, first statement is a leader. Then the label of go to is a leader. Then and the if will be leader. That is the state in the if ij is less than or equal to 5, go to 3 kudukuma. So that is a conditional go to is a leader. Conditional go to is a leader. So this is also a leader. And the next one is the statement after go to is a leader. So this is also a leader. Yeah. So I repeat, the first statement is a leader. Then the label of go to is a leader. So 3 and 2 leader. Then the conditional go-to is the leader. So idu 9 11 leader, and the last rule is the statement after the go-to is the leader. So statement after the go-to na 9 க்கு அப்புறம் என்ன இருக்கு 10. So 10 is the leader. இப்போ லீடரை வச்சுட்டு என்ன பண்ணணும், அப்படி ஸ்டேட்மெண்ட்ஸை பிளாக்கா பிரிச்சிட வேண்டியதான். அப்போ 1 leader, 2 leader, 3 leaderனா 1 is a separate statement. So that will be separately in a separate block. And 2 is a separate statement. So that is separate block. Then 3, after 3, 9 is a leader. So 3 ல இருந்து 8 வரைக்கும் it will be in one block. Okay, so 3 to 8 is another block. Then after that 9 is a block, 10 is a separate block, and 11 is a separate block. Okay, so this is your diagram. Control flow graph. பாருங்க, 1 leader-ஆ இருக்குது, 2 leader-ஆ இருக்கு. So this is separate block, and 2 is also separate block, and 3 after that 9 is a leader. So 3 ல இருந்து 8 வரைக்கும் it is a block, then 9 is a block, 10 is a block, 11 is a block. இப்போ நம்ம கவுண்ட் பண்ணி சொன்னா போதும். எத்தனை இது வருது? 1 2 3 4 5 and 6 nodes are there. Okay, நமக்கு ஒரே ஒரு ஆப்ஷன் தான். So 6 nodes automatically ages பாருங்க 1 2 3 4 5 6 and 7. So your answer is 6 and 7. Okay, in this way you have to construct the control graph, flow graph. Okay, so I repeat. Okay, see here. Determining the leader. First thing is, first statement is a leader. Okay, and the second one is label of go-to is a leader. Then third statement is conditional go-to is a leader. Then the next statement after go-to is a leader. Next statement after go-to is a leader. Okay, so based on this you are defining the leaders and dividing into basic blocks and draw the flow graph. Okay, flow graph or control flow graph. Okay, and you are calculating the nodes. To consider another one, இதே மாதிரி தான் இருக்கும். நான் மேல சொன்னேன் பாத்தீங்களா, consider the following source code, which one of the following is false. சரியா, மேல பார்த்தோம்ல, அதே மாதிரி இங்க என்ன பண்ணிருக்காங்க, which one is the correct optimization. Okay, considering the following code, this is your code and you are asked to find the correct optimization. Okay, so first let us find our answer and then check the correct answer. Okay, so C is equal to A plus B, D is equal to C. Okay, D is equal to C, and the next one is C is equal to C minus E. But D equal to C na, and the statement according to the common sub expression eliminated, that can be eliminated. Okay, so see here, C equal to A plus B. Kindly wait, I think it is in some other color. C is equal to A plus B. And the next statement is what? D equal to C. So D equal to C means both are common. We can eliminate it. Instead of D, we can put C wherever D is present. Okay. And the next statement is C is equal to D minus E. C is equal to C minus E. Another thing, here D equal to C, but here C is equal to C minus E. D equal to E அப்படி இருக்கட்டு. D வந்து A plus B ஆ இருக்குது. அந்த A plus B தான் இங்க கால்குலேட் யூஸ் பண்றாங்க. ஆனா C ஓட வேல்யூ என்ன பண்றாங்க, இங்க சேஞ்ச் பண்ணிடுறாங்க. So you cannot use D in the place of C. So D equal to C as it is. And the next statement, C equal to C minus E. So that is அதை அப்படியே போடணும், அதை ஆப்டிமைஸ் பண்ண முடியாது. Then after that, A is equal to D minus E. A is equal to D minus E. So the same thing. C போட முடியாது because C value has been changed. And the next one is B is equal to B into E. Okay, so B into E, B into E அப்படின்னு பார்க்கும்போது இப்போ அதையும் அப்படியே போட்டுடலாம். ஏன்னா B வந்து அடுத்து யூஸ் பண்றாங்க, அதை டெட்னு சொல்ல முடியாது. So B is equal to B into E, again B equal to D by B. So everything you're important. So no code can be changed. Now see the result. Okay, C equal to A plus B. அங்க என்ன பண்ணிருக்காங்க, அது இருக்கு. ஆனா என்ன பண்ணிட்டாங்க, D எடுத்துட்டாங்க. Okay, so this is not your correct answer. And the next one, D is equal to C வச்சிருக்காங்க, then C is equal to C minus C எல்லாம் வச்சிருக்காங்க. ஒரு statement என்ன விட்டுட்டாங்க, இந்த லைனை விட்டுட்டாங்க. Okay, so this is also not the correct answer. And in the next one, starting என்ன பண்ணிட்டாங்க, C equal to A plus Bங்கிறத விட்டுட்டாங்க. Because A plus B தான் இங்க வருது, D ஓட வேல்யூ லாஸ்ட் வரை வருது. Okay, so here this is also not the correct answer. So your answer will be none of the above. Okay, so அப்போ ஒரு கோடு கொடுக்காங்களா, நீங்க என்ன பண்ணுங்க, ஃபர்ஸ்ட் நீங்களா என்ன பண்ணி பாருங்க, ஆப்டிமைஸ் பண்ண முடியுமாங்கிறத பாருங்க. கண்டிப்பா ஆப்டிமைஸ் பண்ண முடியும் அப்படிங்கறதெல்லாம் சொல்ல முடியாது. Based on the data flow analysis, you have to optimize the code. இப்போ இதுல பாத்தீங்கன்னா காமன் சப் எக்ஸ்பிரஷன் அப்படின்னு சொல்லவே முடியாது. ஏன்னா here A plus B C இருக்குது, D equal to C போட்டுட்டோம். Okay, then after that பாருங்க C ஓட வேல்யூ நெக்ஸ்ட் இன்ஸ்டன்ட்லயே மாறிடுது. பட் D ஓட வேல்யூ கடைசி வரைக்கும் அப்படியே தான் இருக்கு. Okay, in that case we cannot delete this D equal to C. Okay, because it has been rechanged to C equal to C minus E. Right? So that's why this is actually an optimized code. We cannot change it. So your answer will be none of the above. Okay. So any clarification in this question? Any clarification up to this question? Or you can move to the next question. Any clarification, student, or you can move to the next question? Okay, ma. Thank you. Yeah. So next question. So consider this code segment. We are declaring the variable and initializing the value, and we are using loops. Yes, there is I and J loop, and we are calculating some if block, if of I mod 2, which is equal to x plus is equal to 4 into j plus 5 into I. Then y plus is equal to 7 plus 4 into j. Then finally m equal to x plus y. Okay, which of the following is false? மேல காமிச்சேல அதோட இதுதான் நினைக்கிறேன். ஆமா. Okay, so which of the following is false? பாருங்க என்னெல்லாம் பண்ண முடியும் முதல்ல நம்ம பார்த்துக்கலாம். என்ன ஆப்டிமைசேஷன்லாம் பண்ண முடியும்? It is I mod 2. I mod 2 மேல எதுவும் கொண்டு போக முடியுமா? முடியாது. Because I mod 2 will vary. சரி, நம்ம that is code motionல பார்க்கும்போது என்ன பண்றோம், max minus 2 அப்படின்னா max is a constant value. It doesn't change means we can move the code outside the loop. But here I value, it is going to be changed whenever the loop gets executed. So this code motion cannot be done. Then about the some other techniques, 4 into j. So 4 into j, here also 4 into j. அப்ப j equal to 0 இருந்தா இந்த j யும் 0 தான் இருக்கும், இந்த j யும் 0 தான் இருக்கும். Okay, that means 4 into j is a common expression. So அப்ப என்ன பண்ணலாம், திருப்பி மல்டிப்ளிகேஷன் பண்றதுக்கு one time multiply பண்ணி என்ன பண்ணிடலாம், இந்த இடத்துல என்ன பண்ணிடலாம், we can space just let it be t is equal to 4 into j, right? And instead of calculating 4 into j again, we can directly put what, t. And also here also you can put t. Okay, புரியுதா? கான்ஸ்டன்ட் இந்த காமனா இருந்துச்சு, ரெண்டுக்குமே ஒரே வேல்யூ தான் வரப்போகுது. In that case என்ன பண்ணிடலாம், that can be moved outside the block and can be which is equal to t is equal to 4 into j. So அப்போ இந்த லூப்ல வந்துச்சு அப்படின்னா என்ன பண்ணும், t ஓட வேல்யூ என்னதாகும், சப்ஸ்டிட் ஆகும். Okay, so which of the following is false means the code contains loop invariant computation. ஆமா இருக்குல்ல, ij variable இருக்குது. So this is true only. Then there is a scope of common sub-expression elimination. ஆமா இப்பதான் பண்ணோம், common sub-expression எழுந்துச்சு, we can eliminate it. Then there is a scope of strength reduction. இப்போ ஆக்சுவலா உள்ளுக்கு என்ன இருந்துச்சு, மல்டிப்ளிகேஷன் ஆப்ரேட்டர் இருக்கு, அதை நம்ம என்ன பண்ணலாம், it can be done with the help of repetitive addition மாத்தலாம். Okay, எப்பவுமே இந்த மல்டிப்ளிகேஷன் இருந்துச்சுன்னா that can be represented as repetitive addition. So automatically there is a scope for strength reduction பண்ணலாம். So last one பாத்தீங்கன்னா dead code ஏதாவது இருக்கா, ஏதாவது dead code இருக்கா பாருங்க. I and j they are live. Then t is also live because it needs strings x and y. So outside the block also you are needing what, x and y ஓட value வேண்டியிருக்கு. That means there is no variable dead. எல்லாமே லைவா இருக்கு until the end of the program. Okay, so your answer is there is scope of dead code elimination அப்படிங்கிறது false. Okay, so இப்ப நீங்க சாய்ஸ பாக்குறதுனால என்ன பாருங்க, நீங்களே ஒரு ஐடியா கொண்டாங்க என்னென்ன ஆப்டிமைசேஷன் டெக்னிக்ஸ் ஆர் பாசிபிள். இதுல பார்த்தோன்னே உங்களுக்கு என்ன வந்துடும், லூப் இன்வேரியன்ட் வருது. லூப் இன்வேரியன்ட்னா ஐஜே வச்சு ப்ராசஸ் பண்ணலாம். கண்டிப்பா என்ன பண்ணலாம், மல்டிபிளிகேஷன் வருது அப்படின்னா there is a scope for strength reduction. Then காமன் எக்ஸ்பிரஷன் ஆட்டோமேட்டிக்கா வருது, என்ன பண்ணும் 4 into j மேல கொண்டு போயிருக்கும். Okay, so only thing is everything is live or not. இந்த இடத்துக்கு வரும்போது எல்லாமே லைவா இருக்கு. ஆமா, ij x y எல்லாமே லைவா தான் இருக்கு. That means there is no scope of dead code elimination, right? So this is the answer. The next one is peephole optimization is a form of, what will be the answer? Loop optimization ah illa, loop optimization techniques ஞாபகம் இருக்கா? என்ன பார்த்தோம் loop optimization? See here, loop optimization will be the various techniques are code motion, induction variable elimination, then strength reduction, right? So these are the methods, or these are the techniques of loop optimization: code motion, induction variable elimination, strength reduction, right? So now see to it. இப்ப பாருங்க, இப்ப பாத்தீங்கன்னா லூப் ஆப்டிமைசேஷன் கிடையாது. Then local optimization local optimization என்ன அர்த்தம்? It represent the optimization techniques that can be done within a basic block. என்னென்ன டெக்னிக்கா இருக்கலாம்? It may be constant folding, or it may be common sub-expression elimination, or it may be dead code elimination, or copy propagation. Likewise, these are the various techniques of local optimization, right? So this is local optimization. So இதே இது peephole பண்ணலாமா? peephole என்னென்ன டெக்னிக்லாம் பார்த்தோம்? See here, peephole பாருங்க, peephole என்ன டெக்னிக்ஸ்லாம் இருந்துச்சு? That is redundant instruction elimination, that is காமனா உள்ளது, திருப்பி வர்றதை எலிமினேட் பண்ணலாம். Then flow of control optimization, that is என்ன பண்றோம், unnecessary jump அவாய்ட் பண்றோம். Then use of machinery, இது எல்லாமே நம்ம என்ன பண்ணலாம், within the block நம்ம பண்ணலாம். Okay, so that's why peephole optimization local optimization தான். So and the next one பாத்தீங்கன்னா constant folding. So constant folding மட்டும் வந்து எதுக்குள்ள இல்ல, it is just a technique of optimization. So அது செப்பரேட்டா நம்ம வந்து என்ன சொல்ல முடியாது, ஆப்டிமைசேஷனோட மெயின் டைப்னு சொல்ல முடியாது. Then data flow analysis, optimization பண்ணனும்னாலே என்ன வேணும், data flow analysis, but peephole optimization is not a form of data flow analysis. So your answer is local optimization. Okay, peephole optimization is a form of local optimization. And the next one, in compiler terminology, reduction in strength means. இதுக்கு ஆன்சர் பண்ணுங்களா யாராவது? replacing runtime computation ஆல்ரெடி சொல்லியிருக்கேன், நான் எக்ஸாம்பிள் காமிக்கிறேன். reduction in strength na என்னது? You see this example, I show you the example and tell me, post in chat box those who are live in currently live in live situation, kindly post in chat box. Okay, so strength reduction, what I told you about strength reduction, that is replacement of a costly operator by the cheapest one. Okay, that is multiplication can be replaced by repetitive addition. Then power operator or exponent can be replaced by multiplication. Okay, now see the choices. Replacing runtime comparison by compile time computation, replacing loop invariant computation, common sub-expression removing. Then the last choice is replacing a costly operation by a relatively cheaper one. So directly kuduthirukanga. So what is your answer? A, B, C or D? Yeah, very good. At least I got some responses. Yeah, so D is your response. D is your answer, replacing the costlier operation by cheaper one. Yeah, examples na sonnela. And the next one is, which of the following statements about peephole optimization is false? Yeah, so peephole na nama enna paathom, nariya techniques there is redundant instruction elimination, unnecessary jump avoid பண்ணலாம், அப்புறம் algebraic identities யூஸ் பண்ணலாம், machine idioms யூஸ் பண்றத இன்னும் ஸ்மாலஸ்டா மாத்துறது தான் peephole ஓட வேர்ட். சரியா? சோ அப்போ இதுல என்னென்ன ஸ்டேட்மெண்ட் தப்புன்னு பார்ப்போம். It is applied to a small part of code. இல்ல true தான். ஆமா ஆமா true. It can be applied to a small part of code to find the smallest, right? The second one, it can be used to optimize intermediate code. ஆமா intermediate code தான் இதுக்கு இன்புட்டாவே கொடுக்க போறோம். Optimization technique எல்லாமே it will get to get the best out of this. It has to be applied repeatedly. இத வந்து திருப்பி திருப்பி நம்ம அப்ளை பண்ணலாமா? ஒரு வாட்டி அப்ளை பண்ணிட்டு ஆப்டிமைஸ் பண்ணிட்டு திருப்பி திருப்பி அப்ளை பண்ணலாமா? Yes, it can be applied repetitively to get the best code, right? And the next one, it can be applied to the portion of the code and that is not continuous. Continuous உள்ள ஸ்டேட்மெண்ட்ஸ்ல இல்லாத ஸ்டேட்மெண்ட்ல தான் அப்ளை பண்ண முடியுமா? No. Okay, so this is your false statement, right? So it can be applied to any statements. Okay, so non-continuous statements la mattum dhaan apply panna mudiyum அப்படிங்கிறதெல்லாம் கிடையாது. It is a false. So this is your answer. And the next one, substitution of values for names. Okay, substitution for values or names is done by நல்லா பாருங்க, valuesக்கு பதிலா அதை என்ன சொல்ல அந்த whole. For example, I show you an example. See here. Okay, so this is the expression. 22 by 7.0 is an expression and this is the value. Yeah, so replacing an expression by a value will be called as what? Constant folding. So that is the question they are asking. That is substitution of values for names. Names is nothing but the expression. Okay, and values is the result. Okay, so that will be called as what? Constant folding. Okay, local optimization அப்படிங்கிறது it is a main topic. சரி, அதுல உள்ள நிறைய இதுதான் வந்து என்னது constant folding, copy propagation, common sub expression elimination, everything will be come under that. Okay, then about the loop optimization, it is a main topic. Code motion, strength reduction, loop invariant computation, all are under loop optimization. Strength reduction you already know, replacing the costlier by cheaper, right? So what you got is the answer is constant folding. Okay, and the next one, which of the following comment about peephole optimization is true? Yeah, which one is true? Peephole optimization, I think okay, இதே இது பார்த்தோம், ஆனா வந்து கொஞ்சம் வந்து இது மாறி இருக்கு. இஸ் ட்ரூ அப்படின்னு பார்க்கும்போது இப்ப பாத்தீங்கன்னா it can be applied to the small part of the code and applied repeatedly. It can be used to optimize the intermediate code தான். It can be applied to a portion that is not continuous. இது வந்து false நம்ம மேலே பார்த்தோம், இது கிடையாது அப்ப ஆன்சர். It is applied in a symbol table to optimize the memory requirements. Okay, so actually symbol table will be used by all the phases. எல்லா phase-மே யூஸ் பண்ணும். சரியா? So memory requirements குறைக்குமா? மேபி குறைக்கலாம். சரியா? இப்போ நம்ம லாஸ்டா ஒரு எக்ஸாம்பிள் பார்த்தோம், that is in the MCQ-ல. See here, இந்த கோடை வந்து நம்ம ஆப்டிமைஸ் பண்ண முடியல because there is no optimization technique that can be applied. Common expression or dead code எதுவுமே அப்ளை பண்ணல. In that case, the memory requirements cannot be reduced. Okay, so that is also maybe true. But இந்த நாலுலயுமே பார்த்தனா இதை தவிர மத்த 3 points it is applicable to peephole optimization. Okay, so but the main thing that can be applied is the first one. Okay, it is applied to a small part of the code and applied repeatedly to find the smallest best one, right? Okay, so this is about the peephole optimization. So our answer is first one. Now the next one, consider the basic block. Consider the basic block. They are given is CA is equal to B plus C. Just wait for 1 minute. Okay, so consider this block. You're having a set of statement. Okay, so A equal to B plus C, then C equal to A plus D, then D equal to AB plus C, E equal to D minus B, and A equal to E plus B. So the question is the minimum number of nodes and edges and present in the DAG. Okay, and so you are going to construct the DAG. Okay, DAG construct பண்ண போறோம். Construct பண்ணிட்டு நம்ம என்ன பண்ண போறோம்? We are going to find how many nodes. Okay, அப்போ construct பண்ணி பார்ப்போம். See here, let us take the code. Yeah, A is equal to B plus C, the first one. So A எப்படி construct பண்ணுவோம் பாருங்க. B will be created. Initially empty ஆ இருக்கு. So B. Next one C. Right? And next one A. Okay. Sorry, A is equal to B plus C. The operator involved is plus. Right? So make it as a circle. Interior nodes, let it be circle. Right? And next, the label will be A. So for this subtree, it will be A. And the next one, C is equal to A plus D. Right? So A, it is already there. So A will be your left child. Then D will be your right child. Right? So here D. So A plus D. A plus B, which is equal to C. Okay. So இங்க பாத்தீங்கன்னா C already இருக்கு. இப்போ உங்களுக்கு புது வேல்யூ C கிடைச்சிருக்கு. Okay. And next one, நீங்களும் construct பண்ணி பாருங்க. Otherwise 3 hours class இருக்கிறது தூக்கம் தான் வரும். ஆல்ரெடி தூங்கிட்டு இருக்கீங்களா என்னன்னு தெரியல. Okay. And next one, D is equal to B plus C. இப்போ பாருங்க B is left. B already இருக்கா? ஆமா. Okay. So B. So B can divide. We need to increase the size. B. Okay. That is left child. Then C. C pathina. What is that right now new value of C? This is the new value of C. So this is the right child. And between it, what is the operator? The operator is B plus C. So this is plus, right? Which is equal to B. And the next one, E is equal to D minus B. So D இருக்குது, right? So D will be left. And right will be B. B எங்க இருக்கு? இந்த இருக்கு. Right? So this will be right child. And the operation involved will be minus D minus B, which is equal to E. Right? And next one, E plus B equal to A. So E you are having here, right? And B again you are having here. Or B the last vara. B change ஆகல. Okay. Then that can be connected with the operator plus. Right? That is equal to A. Okay. இப்போ பாருங்க, there is no common sub expression எதுமே இல்லை. ஏன்னா கம்மா அப்படின்னு இருந்தாதான் they are equal னு அர்த்தம். Yeah. So here how many nodes are present? Minimum number of nodes and edges. So how many nodes? 1, 2, 3, 4, 5. Okay. Then 6, 7, 8. Okay. So இது பாருங்க nodes 1, 2. இது node தானே? leaves node தான். Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So automatically your answer will be what? 8, 10, 10, 10 வருதான் பாப்போம். 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so your answer will be 8 and 10. Have you understand this? So everyone, DAG construct பண்றது எப்படின்னு தெரியுதா? Or do you want to draw this again? Okay, yeah. Okay, ma, thank you. Okay, so this is your DAG. So syntax tree ஆ எப்படி இருக்கும்? இப்படி நம்ம எடுக்க மாட்டோம். இதே ஒரே B எடுத்துட்டே இருக்க மாட்டோம். For every expression, we need to create a new tree, new node. Okay, but here இதுல இருந்தே உங்களுக்கு என்ன தெரியுது அப்படின்னா B is never change ஆகல அந்த blockல. The same B will be used for all the statements. Okay, so here the answer will be 8 and 10. 8 nodes, 10 edges. 8 nodes and 10 edges. This is your answer. Answer is 3. Right? And the next one. Local and loop optimization can provide motivation for. என்ன வரும்? Local and loop optimization can provide motivation for constant folding. நம்ம சொல்லலாமா? இல்ல. Constant folding is just a technique of what? The optimization, right? And consider. And the next one is peephole optimization. Peephole optimization, it is taking the small part of the program and repeatedly applying the optimization technique to find the smallest spot. Okay, so that is peephole optimization. Then DFA and the constant folding represent, that is you're finding that is folding the expression value, mapping the names or expression to constant. So that is also a technique of optimization. So இந்த நாலுமே பார்த்தோம் அப்படின்னா இந்த மூணும் just a technique தான் இருக்கு. But what you got, the data flow analysis is the concept behind every optimization. Yeah. So data flow analysis information gathered பண்ணாம it is not possible to optimize the code efficiently. Right? So the answer will be data flow analysis. Next, the optimizing compiler. Yeah. So what are the things it will do? Optimization என்ன பண்ணுது? The first thing is optimized to occupy less space. Ama. Yeah, because what you are doing, that is when you're considering the temporary variables, we reduce the use of temporary variables. Okay, so temporary variables, for example, என்ன பண்ற ஒரு 5 variables யூஸ் பண்றோம் அப்படின்னா எப்படி வந்து அட்லீஸ்ட் 1 வேரியபிளா ரெடியூஸ் பண்ண முடியுமா? Likewise, you are thinking of it. Okay, so it will surely occupy the less space. And the next one, less time of execution. So for example, if I take the use of machine idioms, okay, I show you the example, use of machine idioms. Machine idioms. See here. Yeah. So this I equal to I plus 1 எப்படிலாம் நான் calculate பண்ணலாம் அப்படின்னா the various possible statements are, yeah, I will show in the next slide. Yeah, so for I equal to I plus 1, I can write the statement like the start with code. Move I comma R naught. That is, I am moving the I value to R naught. Okay. Then after that, I am adding. Add. Now the I value is in R naught, right? So R naught comma hash 1. Okay. So hash 1 comma R naught. Right. Now the answer is present in R naught. Now I can move it to I. So R naught comma I. Okay. So this is one kind of statement. So இதே இதை நான் என்ன பண்ணலாம்? சிம்பிளா டைரக்டா என்ன பண்ணலாம்? Add. Okay. I comma 1. Sorry. Add hash 1 comma I. So this is the second possible answer. And the third possible answer is INC I. Yes, both are correct. You know, purpose I equal to I plus 1. I increment pannom. So this is one part of code. It is, I can move the I value to R naught. Then I can add the R naught value. R naught like penna irukum, I irukum. Then that will be added with 1. Then the result is stored in R naught. Then I can move the R naught value finally to I, variable I. So this is one part. And the next one is what I can do is just adding the 1 to the I. Yeah, and store it in I. Or I can use the hardware instruction increment I. Okay, so both 3 ways I can do it. Okay, ஒரு single instruction க்கு 3 possible ways இருக்கு. For example, if you're a particular program கொடுத்திருக்காங்க அப்படின்னா each one of you has a unique program. ஒன்னு போல தான் எழுதுவீங்க, think பண்ணுவீங்கன்னு சொல்ல முடியாது. Okay, so among these three, which one is the best one? Likewise, I have to think of it based on some factors. It may be cost, or it may be execution time, yeah, or it may be use of the temporary variables, or it may be use of the memory space. Yeah, so various factors are based on I have to think of it. Yeah, so for example, if your processor doesn't contain this order instruction, then either use panna mudiyadhu. In that case, I have to go for some other things. For example, when it comes to the, I think you studied microprocessor படிச்சிருப்பீங்க. In 8085 microprocessor, there is no such instruction as mul. Mul அப்படின்னு ஒரு instruction கிடையாது. In that case, what you are doing is, in order to perform the multiplication, we go for repetitive addition use பண்ணீங்க. But in 8086 microprocessor, there is an instruction called mul. So, but directly என்ன பண்ணலாம், we can use the mul. Okay. So, based on the processor, likewise, various factors you have to consider when you are selecting the instruction. Right? So one of the factor is execution time. Okay, so இப்போ execution time என்ன பண்ணும், என்னது improve பண்ற மாதிரி உங்க code இருக்கணும். And the next one is your compiler optimization. Compiler should be optimize the code. Okay, so 3 points are true. It is used to optimize the space, and it is used to optimize the time, and it is used to optimize the code. So your answer will be all the above. Yeah, all the above. And the next one, optimization technique which is typically applied on loops. Parunga, tell me the answer. Kindly tell me the answer which can be applied particularly on loop. Loop optimization பார்த்தோம் நம்ம. 3 technique பார்த்தோம். Removal of invariant computation, peephole optimization, constant folding, all of these. Actually, loopல நிறைய technique apply பண்ணலாம். ஆனா particular we can go for 3 techniques. So can you post பண்ணிருக்கீங்களா யாராவது answer? Can anyone tell me what is your answer? Your answer? The technique applied on loops. Removal of invariant computation, peephole optimization, constant folding, and all of this. Anyone post your answer? Okay, very good, Hema. Sorry, your answer will be A, because பாருங்க நம்மளோட loop optimization technique பாருங்க. About the loop optimization techniques. Loop optimization. I show you. Loop optimization techniques here. Okay, so the various techniques are code motion, induction variable elimination, strength reduction. Okay, so these are the 3 main techniques when you are considering the loop. Okay, so your answer will be very good. The answer is removal of invariant computation. Invariant is computation nothing but ij use பண்ணுவோம்ல, there is invariant variables. So அதை வந்து எப்படி நம்ம வந்து simplify பண்ணலாம், how can you can avoid those, yeah, or reduce the use of such variables. That is said to be invariant computation. And the next one, UD chaining is useful for. UD ன்னு பார்த்தோம், UD DU ன்னு 2 chain பார்த்தோம். Okay, so it is useful for the first choice, determining whether a particular definition is used anywhere or not. Second one, constant folding. Third one, checking whether a variable is used without prior assignment. Then all of these. So see this. Kindly wait. I'll show you the UD chain and DU chain. UD chain, DU chain. Kindly wait. Data flow analysis. Yeah. Okay. See here, DU chain is represent when you are given with the definition. What are all the possible consumers of the definition? That is, what are use the definition before it has been redefined. Redefine பண்றதுக்கு முன்னால யாரெல்லாம் அதை யூஸ் பண்ணா. Okay, so that will be DU chain. Then UD chain represent reverse. When you are given with the use, that particular value has been defined by which statement. So that is said to be UD chain. Okay, so now shall we move to the This question, UD chaining is useful for constant folding or kandipa illa. Constant folding idhula varadhu. Okay. Then determining whether a particular definition is used anywhere or not, or checking whether a variable is used without prior assignment. Okay. So the answer will be UD nale enadhu first use da varum. Use ku paranda enadhu definition varum. So your answer will be checking whether a variable is used without prior assignment. Okay, so this is your answer. Check பண்ணிப்போம் இதுதான் answer ஆன. Sorry, your answer is determining whether a particular definition is used anywhere or not. Okay. Definition. Okay. So UD chain is useful for எப்படி எதுக்காண்டி எப்படி கொடுத்திருக்காங்க அப்படின்னா இப்போ இந்த எக்ஸாம்பிள்லயே பாருங்க. See here in this example we are considering the R7. Let us consider the R7. R7 has been used in R10 position. Okay, 10th statement la enna pannirukkom, it has been used. Previously it is defined by where? R9 and 6. Okay, so we are dealing the definitions where it has been defined. அப்போ இங்க யூஸ் பண்றோம்னா வேற எங்க அதை டிஃபைன் பண்ணிருக்கோம் அப்படிங்கறத அதை டிஃபைன் பண்ணுது அப்படிதானே. So 10 is the place where it has been used. 6 and 9 where it has been defined. Okay, so that's why they are telling the answer to be determining whether the particular definition is used anywhere or not. Okay, so it will define you the use of a particular definition. UD chaining. And the next one, optimization of the program that works well within the single basic block. Your answer, yeah. So இதுல இருந்தே ஆன்சர் இருக்குது, நம்ம ஆல்ரெடி தெரியும். Local optimization another, the optimization within a basic block. Okay, then global means between the blocks. Then loop controlling எல்லாமே என்ன இருக்கும் அப்படின்னா, it is a concern with the loop. That is loop அப்படின்னா என்னதும், it may be some conditional jump or unconditional jump or some என்ன சொல்ல, இந்த if I is less than 10 go to 3 அப்படின்னா பார்ப்போம்ல conditional jump. So that is concerned with the loop uncontrolling and loop controlling. Okay, so here what they are telling, optimization of the program that works well with a single basic block. ஒரு block-க்குள்ளே optimization அப்படின்னா அது என்ன அர்த்தம், ஆட்டோமேட்டிக்கா உங்களுக்கு தெரிஞ்சதுதான் local optimization. Okay, and the next one, a variable x is said to be live at a statement si in a program if the following three conditions hold. சரியா, நம்ம லாஸ்ட் ஒன்று பார்த்தோம்ல லைவ்னஸ் அனாலிசிஸ் அப்படின்னு. லைவ்னஸ்னா என்ன அர்த்தம், இப்போ ஒரு எக்ஸோட வேல்யூ லைவ்னா என்ன அர்த்தம், அவருடைய டெஃபினிஷனுக்கு அப்புறம் அது யூஸ் பண்ணியிருக்கோம், அந்த யூஸ்க்கு இடையில என்ன பண்ணல, வேற எதுவும் வந்து டெஃபினிஷன் இல்லை. I show you that slide. Liveness, live uses. See here, பாருங்க, x has been defined in this particular instant and x has been used in this instant. Before this definition and use, there is no other definition. That means it is said to be live. Yeah, so this is what we call as liveness analysis. பாருங்க, liveness analysis represent for each point and for each variable determine whether y can be used before it has been redefined. Yeah, so this is said to be liveness analysis. அதே இதுதான் அவங்க சொல்றாங்க, a variable x is said to be live at a statement si, right? And they are given the conditions also. There exists a statement sj that uses x. ஒரு ஸ்டேட்மெண்ட் எடுக்கும், அதுல x வந்து யூஸ் ஆகுது. And the next one is there is a path from si to sj in the flow graph corresponding to the program. Yeah, and the path has no intervening assignment to x. Okay, இடையில வேற எந்த அசைன்மெண்ட்டும் x-க்கு இருக்க கூடாது. Okay, so இப்படி இருந்துச்சுன்னா அதை என்னன்னு சொல்றோம், x is said to be alive. Okay, so இப்போ இதுல என்ன சொல்றாங்க, the question asked is the variables which are live both at the statement in basic block 2 and basic block 3, okay, in the above flow graph. So they are given the conditions also and they are given the flow graph. Flow graph கொடுத்துட்டாங்க. You are asked to find which variables are that is live at block 2 and block 3. So block 2 block 3 ல எது லைவா இருக்கு அப்படிங்கறத பார்க்கணும். Okay, so when you see this graph, பாருங்க, p is equal to q plus r, then s is equal to p plus q. அப்ப p க்கு வந்து ஏதோ ஒரு வேல்யூ இருந்திருக்கு, now it is said to be redefined. Then p oda value inga use ஆயிடுச்சு. That means it has been it may be dead. Okay, that is p oda value adukapra looping la adukapra enna varala. And the next one is s is equal to p plus q. But p முடிஞ்சதா. next q பாருங்க. q பாத்தீங்கன்னா q is used and q is used and here q is defined. Okay, so q redefine பண்ணியாச்சு. அதுக்கு முன்னால இந்த லூப்க்கு வெளியில q ஏதாவது வேரியபிள் டெஃபினிஷன் கொடுத்திருப்பாங்க. At this instance q has been redefined. That is q is the previous initial definition of q is dead. Okay, and the next one or. So or just they are using and here they are using. Okay, and here also they are using. Okay, there is no definition of or. Okay, in that case or is live throughout. Okay, so in the loop ku munnala varraknaala or value enna irunducho the same or value will be repeated over all the blocks. Okay, so or is live at block 2, or is live at block 3 as well as or is live at block 4. Okay, so next பாப்போம். next பாருங்க. next எனக்கு pq not live னு சொல்லியாச்சு, r வந்து live சொல்லியாச்சு. இப்போ next என்னது s is equal to p plus q. அப்ப s already some variable has been defined, some definition is defined, but now it is redefined. So the old definition has been dead. Okay, so s is also used. So s அப்படியே விட்டுறலாம். And the next one pq already நம்ம சொல்லியாச்சு. இப்போதைக்கு நம்ம r மட்டும் தான் என்னதா இருக்குது, லைவா இருக்குது. Next u is equal to s equal to v. s விட்டுட்டோம். Next u v பார்க்கும்போது v is already has been redefined here. Okay, v already வேற ஏதோ definition இருந்திருக்கு, அதை நம்ம இங்கே யூஸ் பண்ணியிருக்கோம். இப்போ அதை redefine பண்ணியாச்சு. In that case v also dead. Okay, the next one is u. u பாத்தீங்கன்னா u is equal to s into v இப்பதான் நம்ம define பண்றோம், and u is used here and here also you are using and there is no redefinition. In that case u is also live. Okay, so at the block 2 and 3 what your answer is r and u. Okay, so r and u will be live at block 2 and 3. Okay, I repeat. So p s u q r எல்லாமே செக் பண்றோம். மெயினா பாத்தீங்கன்னா டைரக்டா பார்த்தா நம்ம சொல்லிடலாம் q is not live னு சொல்லிடலாம், b is not live, as well as p has been defined, has been used, s has been defined and has been used within the same block. That means it has been redefined again and again. Okay, in that case we can go for only u and or. Okay, so your answer is r and u. Okay, so this is about the some of the multiple choice questions or gate based questions I have gone through. Okay, now we are going to see some other questions also. So up to now, is there any clarifications? Is there any clarifications? Now we are going to see some more gate-based questions. Any clarifications today? Shall we move on to the next one? Okay, thank you. So next one, I shall copy the link. Kindly wait, let the link open. Okay. Okay. So let us see directly to the. Okay. Or we can take some of these questions also. How many parts of compiler? மத்ததையும் வேணா பார்த்துட்டு எப்படி மத்தது பார்த்துருவோம். Yeah. So how many parts of a compiler are there அப்படின்னு பார்க்கும்போது how many parts? That is your answer will be B2. Okay, so how many parts of the compiler means it contains two parts, that is front end and back end. Yeah, so parts of compiler அப்படின்னு பார்க்கும்போது the phases அப்படின்னு பார்க்கும்போது என்ன phasesலாம் இருக்குது, lexical analyzer, syntax analyzer, semantic analyzer, then intermediate code generation, code optimization, and code generation. So totally 6 phases are there, right? So the 6 phases can be grouped together into 2 parts. Okay, so that is front end and back end. இல்லைன்னா நம்ம என்ன சொல்லலாம் அப்படின்னா there are 2 parts of compilation சொல்லுவாங்க. analysis synthesis, right? That is lexical, syntax analysis, semantic analysis will be grouped together as analysis phases. Then synthesis phases அப்படிங்கிறது மீதி உள்ள 3 phases. Yeah. So ma'am,
can you please zoom the page?
Okay ma'am.
Okay, thank you.
Visible இல்லையோ ma'am?
ஆமா மேம், லைட் லெட்டர்ஸ் வந்து குட்டியா இருக்கு.
Oh, I can zoom in. Is it visible now?
Yes ma'am.
Okay ma'am, thank you. Okay, next one is, so 2 parts of compilation is analysis and synthesis. And next one, grammar of the program is checked at dash phase of compiler. I think you already know all these things. So இத பார்த்துட்டு அடுத்து code optimization ல உள்ள related ஓட இதையும் பார்த்துடலாம். Can anyone tell me which phase we are checking the grammar? Your answers? I show you once again. The grammar of the program is checked at the phase of the compiler. Surely code generation இருக்காது, code optimization இருக்காது, checking எல்லாமே analysis phase ஓட முடிஞ்சிரும். Okay, so the remaining is semantic analysis and syntax analysis. Semantic will be checked only for the type. Okay, so automatically what you got, your answer will be okay, syntax analysis, right? Very good. Yeah, so the answer is syntax analysis. And the next one, dash is a process of finding a parse tree for a string of tokens. A very simple one. So you are from the tokens, you are constructing the parse tree means what is the process? The process will be processing, analyzing, recognizing, tokenizing. All these things the same thing. So what will be the answer? Your answer will be parsing. So parsing is the process of finding the parse tree. Then what is the action of parsing? The source program into syntactic classes. Okay, syntactic classes. So source program into proper syntactic classes. The source program input varrade edula da lexical analysis. So lexical analysis will be your answer. And the next one, compiler can check what errors. Okay, it can check for logical types of errors. பார்த்திருப்பீங்கன்னு நினைக்கிறேன். The various errors are, first one is lexical error. That is, errors will be encountered in the first 3 phases. அதாவது the analysis phase ல என்ன errors வந்தாலும் that will be encountered and will be rectified within that itself. Okay, so lexical errors. Then the second one is syntactic errors, and the third one is semantic errors. So lexical errors is nothing but if a particular set of characters doesn't form any token, that is, it doesn't follow any pattern, then that will be called as what? Lexical errors. Then syntax errors, you already encountered it. For example, if I specify if A equal to B, right? Or A equal to B means that is a small statement, right? Actually, what should be present? It should be a conditional expression, A equal to B. Likewise, some syntax error means it will produce the syntactic error. Then semantic error is concerned with the type error. Okay, if I have the statement like this, A is equal to B plus C, then it should check whether A, B, and C are compatible operands. Okay, then that will be semantic error. So your answer will be logical errors also can be checked, syntax errors also can be checked. Answer is okay. No, logic errors check பண்ணும் actually. Okay, so but mainly syntax errorங்கிறதுனால போட்டிருக்காங்க, but actually both A and B should be the correct one. Okay, lexical errors அது கொடுக்கல, then syntax errors கொடுத்திருக்காங்க, semantic errors கொடுக்கல. So based on the phases they are telling the answer. So syntax error is the answer. And the next one, இது already பார்த்திருப்பீங்க, grammar that produces more than one parse tree for some sentence is called as ambiguous grammar. Already பார்த்திருப்பீங்க TOC லே ambiguous grammar. Then lexical analysis is about breaking a sequence of characters into tokens. This is already a very simple one. And the next one, dash is the most general phase structured grammar. Okay, structured grammar, that is, it will be, the answer is context sensitive grammar. Okay, so from the name itself we can define. Okay, it should be a structure one, and most general phase அப்படின்னு represent context sensitive. Free represent there is no structure. Okay, so that's why the answer is context sensitive grammar. Okay, and the next one, I am searching for some optimization related question. Next, the dash is considered as a sequence of characters in the token. So sequence of characters forming a token நம்ம என்னன்னு பார்த்தோம், lexeme, right? The answer is lexeme. Then what is the name of the process that determines whether the string of tokens can be generated by a grammar? Okay, so that is nothing other than the parsing. சரியா, parsing தான் என்னது, grammar check பண்றது, type check பண்றது semantic analyzer. Okay, then dash is a software utility that translate code written in high level language to a low level language. So high level language to low level language, automatically it is compiler, nothing other than the compiler. Then other point, I think you hope you all know about it, the cousins of compiler. Actually the translation process from high level to low level, that is machine to machine language conversion can be done with the help of some other components also. They are called as the cousins of compiler அப்படின்னு சொல்லுவாங்க. The various cousins are preprocessor, then assembler, linker or load editor. Okay, so these are the three cousins of compiler. Yeah, so which help in the process of conversion from high level to low level language. Okay, so preprocessor என்ன பண்ணுனா, from the name itself you can define pre-processing everything. That is, when you're considering the C code, the first line of your code will be including the header files, right? So then defining the macro also. So that is said to be what, preprocessor. So by என்ன நடக்கும்னா, before the execution itself, the header files you have included, then the macro values you have defined, everything will be processed. That is said to be preprocessor. Then assembler is, I already told, it takes the assembly code and generate the machine code. Okay, and the next one is linker or load editor. It will link all the modules that is spread in various locations. Yeah, wherever locations la sub modules irukkalam, adu ellathiyum சேர்த்து ஒரு இதா link பண்றதுக்கு that is the purpose of what, loader or link editor. Okay, stored in a single location. Okay, so these are the cousins of compiler, you have to know about it also. And the next one, yeah, then this is already a seen the same thing. Okay, let us go to the next one. That is next link. Okay, see this code for the C program given below. Is it visible? Is the screen visible? Or I have to okay, ma. Yeah. See here, for the C program given below, the statement does not hold true. Last our example pathama, they are given a code and you have to tell which one is not possible. Yeah, so here 4 into j, 5 into y. So automatically பார்த்தோனே என்ன தெரியுது, 4 into j is a common sub expression, right? So multiplication வந்துச்சுனாலே automatically there is a scope for strength reduction also. Okay, so a holds true, there is a possible for strength reduction. Then there is a possible for common sub expression elimination. then dead code அப்படின்னு பாருங்க dead code ஏதாவது பண்ண முடியுமா இப்போ x plus equal to 4 into j 5 into y. So this is just a loop. In that case, what happens? This x and y will be used in the future. That is, after this block, surely this x and y will be used. That means there is a scope. There is no scope for dead code elimination. Okay. So your answer will be there is a scope for dead code elimination is wrong. Yeah, strength reduction pannalam, common expression, sub expression elimination is also possible. The only not possible thing is dead code elimination. Okay, likewise they will ask, surely ask. Okay, so they will given a code, then from the code you have to apply what are the possible what are the not possible optimization techniques as well as what are the possible optimization techniques, that also you have to know. Yeah, and the next one is in compilers, generation of intermediate code based on abstract machine model is useful because, you can see here, compiler generation of intermediate code based on abstract machine model is useful because syntax directed translation can be written for intermediate code generation to generate code for real machines directly. Portability of the front end of the enhanced implementation of lexically is easier. Okay, so here we are generating the intermediate code on the second part then in the back end, right? Front end only the analysis will be there. Yeah, so why means the implementation of lexical and syntax analysis is easier. That's why most of the errors error la varumo that will be encountered and rectified in the analysis phase itself. So that's why in the generation of compiler, that is intermediate code that is based on the abstract machine model. So the answer is this one, that is implementation of lexical and syntax analysis is easier. So that's why when you're grouping the phases, we can group the phases into any passes. Yeah, mostly the analysis phase will be in the one part. Yeah, and the remaining phases in the second part. Because எல்லாத்தையுமே ஒரே பாஸ்குள்ள வச்சோம் அப்படின்னா it is very difficult for us to hold a large block of memory until all the process produce their result. So that's why dividing the phases into pass ன்னு படிச்சிருப்பீங்க. Okay, so pass divide பண்ணிடுவோம் group for example lexical and syntax and semantic analyzer in one pass. In that case the input will be given as source code will be given as input, and the output of the pass will be the syntax tree with the type information, right? Then that will be given to the next group that contains the remaining phases. Means the input will be the syntax tree with type information, the output will be the target. Okay, so that is the purpose of efficient parsing. So that is implementation of lexical and syntax analyzer. Okay, kindly wait.